Okay, so from yesterday and the day before, we looked at 4 different ways that angles could be on a circle. They could be at the center of the circle, they could be inside the circle, they could be on the circle, and they could be outside the circle. So what we talked about was that if the vertex of the angle was at the center of the circle, the measure of the angle equaled the measure of the arc. That was probably the easiest one. That was a central angle. Inside the circle, that means it's not at the center, but it's not all the way to the outside. In that case, the measure of the angle equaled half the measure of the two intersected arcs. So whatever arcs the angles made, those two arcs added together, half of that gave us the measure of our angle. If we were right on the circle, remember there were 2 ways we could do that. We could be inscribed, or we could be with just the vertex on the circle with tangent and secant lines coming together right there. And in that case, the angle, whoops, not the arc, my bad. The angle was half the arc. Pretty basic. That one was an easier one. Lastly, as soon as the vertex of our angle moves outside the circle, the measure of the angle was equal to half the measure of the farther away arc minus the measure of the closer or nearer arc. That wasn't so bad. We did pretty well with that. Kind of had a pretty good handle on that. Okay? Let's get this off of here. Beautiful. Oops. Okay, so there are also 4 pairs of segment relationships. Angles and segments kind of go hand in hand for us with circles. We can have 2 chords intersecting in the circle. That might look something like this. Chord, chord, yay. We might have 2 secants. That means we have a segment that touches the circle in 2 places, intersecting with another segment that intersects the circle in 2 places. We could have 2 tangents. We have studied this one once already. And we could have a secant and a tangent. So in that case, we have our secant line, and we have our tangent segment. Right, 2 chords, endpoints on the circle, intersecting inside the circle. Secant touches the circle in 2 places. Tangent touches the circle in 1 place. A secant in 2, tangent in 1. Based on how many times each segment intersects the circle, we will have one of the following things happening here. Okay? Depending on how many times it intersects, one of these things will happen. The first one that we're talking about today comes on your note sheet, and it says chord and chord. It's in the top left corner on one of the sides. It says chord and chord. Here's what it says. If 2 chords intersect in the interior of a circle, then the products of the lengths of the segments of the chords are equal. Oh my gosh. Too much. Here's how it works. We have our circle, and our chords intersect. And when they intersect, each chord is broken up into 2 parts. This chord is broken up into those 2 parts, and this chord is broken up into those 2 parts. So we have the 2 red parts and the 2 blue parts. Up here it's shown like this. We have this blue part, EB, and the red part, AE. That is the whole chord, AB. We also have the green part from EC, and it's purple, we'll call it the black part from ED. Those segments, those 4 little parts, came from breaking up the 2 chords. And the product of the broken parts from each one equals the product of the broken parts from the other one. Okay? Here we have AE. That's this piece right here. Times EB. And that equals CE times EB. So if you take part of one, multiply it by the other part of that one. That equals part of the other, multiplied by the other part of the other. So for chords, it's all about looking at the individual pieces of each chord breaks up into two spots, and then we multiply those. Notice they are not congruent. Please notice that. If it breaks it up, it doesn't mean it bisects it. It means that it's been chopped in some sort of way that matches the way the other one has been cut. Okay, we'll look at two examples. These two examples are also on your sheet. If you follow your sheet straight across, you can see that, yeah, we have two chords here. Let's do a chord example. Here's the first one. Find the value of the variable and the length of each chord. Okay? We have two chords here. We'll call them the red chord, GH, and the blue chord, FE. And we have to look at one part of the chord times the other part of the chord equals one part of the chord times the other part of the chord. So if we look at our red chord, GH, GH is broken up into GJ times JH. That is supposed to be, and will always be, equal to the two parts of the blue chord multiplied. Oh, I don't have my colors. Those are FJ and JE. GJ times JH equals FJ times JE. GF, okay, we look at the picture. G to F is 14, right? Times JH. It's hard to tell, but JH is going to be X. That equals FJ. FJ is 7, and JE is 10. So we do it 7 times 10. And then we keep solving it. 14x equals 7 times 10. Well, that's 70. Divide both sides by 14. X equals 7. Oh no, x does not equal 7, my bad. X equals 5. X equals 5. Okay, that's great. We found the value of each variable. The length of each chord comes next. Chord, the red one, GH, is 14 plus x. So GH was 14 plus x. 14 plus 5, and GH is 19. FE, on the other hand, is actually pretty easy. It's 7 plus 10. We knew both parts. FE is 17. Okay? FE is 17, GH is 19. They are not congruent. No part of them is. Look at this part right here. This 14 is 14. The x is 5. 14 and 5, very different. If we keep looking, let's look at the blue ones. 7 and 10. 7 and 10 are different, and they're different than 14 and x. They aren't congruent. Their products match. Okay, we can do the same thing over here. We have chord WY. WX times XY. That's going to be equal to ZX times XV. WX, XY, 6 and 12. 6 times 12. That equals ZX times XV. The whole thing is ZV. XV is 8. ZX is D. D times 8. 6 times 12 is 72. 8 times D is 8D. Divide both sides by D. And 9. Divide both sides by 8. And D equals 9. And if D equals 9, we come back up to the top. We have to find WY, that whole segment, we have to find it. WY has a part that's 6 and a part that's 12. The whole segment is 18. And the other one, ZXXV, ZX, oops, sorry, not ZX, so I want to find the whole length. X is just the intersection point. The whole length is ZV. That was D plus 8. D is 9, so 9 plus 8 is 17. And there it is. There's chords. Not too bad. Okay? Chords aren't too bad. We can do those pretty easily. Just set it up so that you have one piece times the other piece equals one piece times the other piece just from the other segment. So two pretty decent examples. I hope you wrote those down. Take a second to write them down and have them, because this is the kind of stuff you're going to be doing in your homework for today. Okay? So chords, not too bad, like I said. Jot this down, not too bad. The next thing we will do, let me get this off of here, otherwise it's going to carry over. The next thing we do is this. Secant and secant. Remember, secant is a line, or secant is a line that intersects in two places. Here it's a segment that intersects in two places. And if two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. Okay, I don't need you to know the word. That's why I flew through them. What I need you to know is this. Highlight it, star it, put a happy face by it, do what you gotta do so you remember that. The whole secant times the outside part of one equals the whole secant times the outside part of the other. The whole thing means that we start at A and we go all the way down to E. That's that AE. The outside starts at B and goes to E. AE and BE. Same thing, the whole thing means that we start at C and go all the way to E. E is their common intersection point. The outside means we start at D and we go to E. So for a secant, it's about looking at the whole thing compared to the outside. Whole thing compared to the outside. Okay? With secants, we need to be careful that we are adding the whole thing together and then just looking at the outside piece. That outside piece gets used when you figure out the whole thing, because it's in the total, and then it gets used again when you multiply. So be careful with that, please.